Okay, so we're at the fourth video for solving equations. This time we're getting a bit more complicated. Like this is definitely a bit more into the grade 11 stuff. You probably would have seen this in grade 10, but you're just expected to master it once you get to grade 11. So we want to solve this. Want a radical form. Okay, so to find a radical form means there's going to be a root in there somewhere. And also if we look at the product sum method, we'll notice that there are no two numbers, for example, that will multiply to minus 1 and the sum will be 2. If it was a plus 1 as product, it would work, but because it's minus 1, it doesn't work. Same thing with 6 and minus 8. Often when the product is smaller, it can't be done. That's not always true, but it's often like that. So we'll just erase these. We can't use that method. So what we'll have to do is use a different method called completing squares. So this is the algebraic method. You can always use a graphing method that always works. And in the next video, we'll see a formula method that will give you the answer also that you might find easier depending on your case. So you have to make sure when you're solving these that you know if your teacher wants you to use the formula method or the completing squares method. So completing squares will give us actually the vertex form. Once we have the vertex form, we'll be able to use inverse bid math to solve it. So what we're trying to do is find the y equals a bracket x minus h squared plus k. That's a generic form of the vertex form. So our first one. This one's easier because there's no fractions in there. So we have x squared plus 2x. We leave the space. Then we do minus 1. We leave another space. Equals 0. So what we need to do here is make a perfect square. So we've already seen that to have a perfect square, you need a perfect square at the end here. So in this perfect square, the root is half of your b value. So here essentially if we want to find the c value goes here, c equals b over 2 squared. So what's b? B is 2. So 2 over 2 squared equals 1 squared equals 1. So that means we have to add a plus 1. But so we don't change the value, we could add a plus 1 on the other side of the equal. That would work too. But instead we'll add a minus 1 on the same side of the equal. So we add something, we take it away again. Now the reason for that is we'll be splitting this in half. Right there. So I'll just erase this work I did. So here this is a perfect square. It will become x plus 1, so the variable, the sign of the b coefficient, and the square root of 1, we put a squared, and then we have minus 1 minus 1, it's minus 2, equals 0. Okay, so we'll be using inverse bed math. So we'll start by looking what we'd have to do if we were to evaluate. Let's say we gave you a value of x and you wanted to evaluate this. So first thing in bed math is the bracket. Is there something to do in the bracket? Yes, you'd have to do plus 1. Once the bracket's solved in the outside, you have a power of 2 and a minus 2. You do the powers of 2 first. So this would be the power of 2. So I'm using the Texas Instruments calculator button that has a little circumflex sign that means power. And then there's a minus 2. Now to solve this, we'll have to do inverse. We have to reverse the order and reverse the operation. So instead of minus 2, we will do plus 2. Instead of power of 2, we'll do the square root. And then instead of plus 1, we'll do minus 1. So we don't want to look at this anymore. So we go here. First thing we do is plus 2 each side. Okay, so plus 2. And this will become x plus 1 power of 2 equals 2. So we are done with plus 2. Now we have to do square root of each side. Now power of 2 and square root cancel each other out. You're left with x plus 1. And here, because we're solving, it's important to realize that when you square root, two values can be considered, either the positive or the negative of root 2. So we are done the second step, which is doing the root. We're left with the third step, which is minus 1 each side. X with nothing stays the same. 1 minus 1 becomes 0, so we have x plus 0. We just write the x. Now here, you can't put the root and the negative 1 together, especially that the root is plus or minus. So by convention, we usually put the whole number first. So you would put the whole number first, which is minus 1, and then you do plus or minus root of 2. And that's the answer for the first one. There's actually two answers. There's negative 1 plus root of 2, and there's also negative 1 minus root of 2. So if we write it out, it would be x equals minus 1 plus root of 2, or x equals negative 1 minus root of 2. Okay. So I'll just erase our little table here that was just there to help us. Now, b will be a bit longer because we have an a coefficient. That always complicates things a little bit. It starts off pretty much the same way. So we have 3 and then we have x squared. And because I want to keep this as a 1, I'll open a bracket here and I'll divide stuff by 3. So we have minus 8/3 x. We leave a space. The plus 2 is there. And then we leave a space again. Close bracket. Equals 0. So what needs to go in here? So like we saw before, the value of c equals b over 2 squared. So b is 8/3. We divide it by 2 squared. So this becomes 8/6, because 8/6 is half the size of 8/3. Now we can reduce this a little bit. We can divide it up and down by 2, so that will give us 4/3. And we haven't squared it yet. So 4/3 squared becomes 16/9. So here we're adding 16/9. Okay, and I just noticed I forgot to divide by 3 this 2 here. That has to be 2/3. So you'll notice I took out the 3 from all 3 terms. So 3 divided by 3 is 1x squared. Negative 8 divided by 3 is negative 8/3. 2 divided by 3 is 2/3. And now to find what I added to complete the squares, it's always the b term, or the term in the middle. I divide it by 2. Here I could simplify a bit to 4/3 after dividing, and then I square it, and I have to add and subtract it. Okay, so I'll just erase the extra work I did here. Okay, so to do this, I'll add an extra square bracket. Here I have a perfect square. So this perfect square will be the root of x squared, which is x, the sign of the middle, which is minus, and then the square root of 16/9. 16/9, if you square root, it becomes 4/3. Now we have plus. So we have to figure out what this 2/3 minus 16 over 9 is. So 2/3 is the same thing as 6 over 9 minus 16 over 9. So 6 minus 16 is negative 10. And this is my common denominator. So we have minus 10 over 9. Okay. So instead of this plus here, instead of doing plus negative, I'll just erase half of that. And we'll do minus 10 over 9, like this. Now, if I was asked to complete squares, I would take the 3 and distribute it inside. That means I would multiply the 3 times the first term, which is the factor, and the 3 will be multiplied by the negative 10 over 9. But since I'm asked to solve, I don't need to do that. So what I'll do is I'll be dividing by 3. So if I were to evaluate this, the first thing I'd have to do is negative 4 over 3, then the second thing would be power of 2, then I'd have to do negative 10 over 9, and the last thing I'd have to do is multiply everything by 3. So since I'm trying to solve for x, I have to do the opposite in the opposite order. So first thing I'll do is I will divide by 3 each side. 3 into 3 simplifies to 1. 0 divided by 3, that stays 0. So that was easy. So we have x minus 4 over 3 squared minus 10 over 9 equals 0. Next step, I will add 10 over 9. Essentially, you'll notice I'm always getting rid of what's farthest from the variable. The x is here, and it's in a bracket with the power of 2, and the negative 10 over 9 is the farthest one. That's the one that's going away first. So plus 10 over 9, like this. So what's left, we have just the bracket, x minus 4/3 squared equals 10 over 9. So next step is to get rid of the power of 2. The opposite of that is the square root of each side. So we will be left on the left with just x minus 4/3. And on the right hand side we put plus or minus root of 10 over 9. And finally, plus 4/3 on each side, we're left with x equals 4/3 plus or minus root of 10 over 9. So this is an interesting one because you can actually simplify it a little bit. We'll go x equals 4/3 plus or minus root of 10 over root of 9, and root of 9 here simplifies to 3. So finally, we can write both of our answers. So the first value of x possible is 4 plus root of 10 over 3, and the second one is x equals 4 minus root of 10 over 3. So I just write the 3 once because it's a common denominator, and when you're dealing with fractions, you can only add them if the denominator is common to both fractions. So there we go. That one was a bit long. It's unfortunately easy to get mixed up with fractions. Like each step is exactly the same. Whenever you're completing squares, you always have to take out your a coefficient and that's why you can get fractions. You'll notice here, that's why we have thirds everywhere, because there was a 3 originally in front of the x squared. And then you always have to do your value of the b coefficient divided by 2, square it, then you add and subtract it, and then you write your perfect square. And then if you're asking to solve, you just do reverse BEDMAS until you get to x equals something. In this case, you get 2 answers, because often when it's a power of 2, you'll get 2 answers. Okay, so we're done for this one.